Hello, this is Mr. Hansen. I'm looking at several different graphs with you, and I wanted to help you understand some things about them. So let's start with number 1 right up here. It says age and allowance, and this is kind of a sad story about a parent who never let his kid grow up and always gave him the same $10 a week for years and years and years. And so there you have it right there. That's the graph of his function. If we were to try to write that as an equation, it would be y equals 10, because our allowance is always going to be $10 there. Okay, let's take a look at another one. This time you've got Mr. Hansen in his hot rod. You've got 1 hour, he's gone 100 miles. 2 hours, he's gone 200 miles. And then 3 hours, 300 miles. You might recognize here, every time we go over 1 hour, we're going up 100 miles. This is rise over run. So 100 over 1, that's my slope. We times slope by the whatever number x could be, 1 hour, 2 hours, 3 hours, and so on. And you get what y is, the number of miles. So y equals 100x. This is also a linear equation, and we have a slope of 100 for this linear equation. Let's take a look. Oh, and there's a y-intercept of 0, so something like that. Let's take a look at the next equation. Here we have miles driven and cost. So this might be a rental car. So at 0 miles driven, it costs you $5. At 1 mile driven, it costs you $7.50, and at 2 miles, it costs you $10, and so on. So if we were to write an equation for this one, we would write, let's see, we're comparing miles to cost. Each time we go over 1 mile, we're going up like $2.50. So 2.5 over 1, and our x is miles driven, so times by x. And then we have to add the 5, because we started at 5, not 0, plus 5 equals our cost, y. Let's just try this. Let's plug in 3. So 3 times 2.5, that's going to be $7.50, plus 5 should be right there at $12.50, and sure enough, it is. Okay. So we have a slope here, 2.5 over 1. We have a y-intercept here. It starts right at 5 on the y-axis. Okay, last one. We have days camped and packs of hot dogs left. So at 0 days, you have 4 packs of hot dogs. After 1 day, you used a package of hot dogs. After 2 days, you used another package. After 3, you used 1. And after 4, you used 1, and so on. So let's see here. It looks like each time we go over 1 day, we're going down 1 hot dog. So 1 day, -1. So that's the slope there, -1. And we times that by the number of days. And let's add 4 for the y-intercept. Let's just see if this works. Let's plug in 2. -1 times 2 is -2, plus 4 is 2. And at 2, we'd be at 2. So notice the difference in this last one is we have a negative for the slope, so it's going downhill. The middle two, we had a positive for the slope, so it was going uphill. And then the first one we had, there was no slope there was just a y-intercept, so it's going horizontally. So these are all examples of linear equations. They all take the form y equals mx plus b. In the first one, m was 0, so it's just like y equals b. In the second one, number 2, b was 0. In the third one, you had a slope, and you had a y-intercept of 5, and in the fourth one, you had a negative slope and a y-intercept of 4. All right, so these are all linear equations. They are also all functions, meaning that for every input, one output. For example, when this boy was 1 year old or 2 years old, he made $10. When he was 4 years old, he made $10 again. When he was 6 years old, he made $10. here on number 2, you can see that for every input there is exactly one output. So these are all functions here. Let's take a look at some functions that are not linear equations. If you had a jar full of jelly beans, you could, people might guess how many beans are in the jar. Your guess would go along the x-axis, and how much you were off by would go along the y-axis. So if there were exactly 3 jelly beans in the jar, you'd be off by 0. But if there were 4 jelly beans, you'd be off by 1. Or if there were 2 jelly beans, you'd be off by 1. That's what makes this V-shaped here. So it's almost like a linear equation, but you've got 2 lines. And the way we deal with that is we say y equals, and you can kind of tell that the slope is 1 or negative 1. And we're going to go y equals absolute value of x plus, oh, I'm sorry, let's try this again. Y equals absolute value of x minus 3. And let's just see how this works. You might remember absolute value just means distance from 0. You put a number in there, and if it's negative, it becomes positive. So let's put in 4. 4 for x, 4 minus 3 is 1, and the absolute value of 1 is 1. We're off by 1. Let's put in 2. 2 minus 3 is negative 1. The absolute value of negative 1 is 1, and we are off by 1 again. So that's a function that involves absolute value. We don't really consider it a linear function anymore because it has some different slopes here. It's made up of 2 different lines. So we call it a linear piecewise function because there's really 2 pieces to this. Let's take a look at another function. If you had a square and you looked at the side length and it was 1, the area would be 1. So here's the point 1, 1. If you had a square and the side length was 2, the area would be 4. So there's the point 2, 4. And then if you had one that's 3, it would be 9. So 3, 9, 4, 16, and 5, 25, and so on. So what's happening here is we are timesing the length times the width, or the length times itself, since the length and width are the same in a square. And all you're really doing is saying anything times itself equals the area. So this is what we call a quadratic equation, because you're squaring the x. You're squaring the x, it makes it a quadratic equation, and you'll notice how it kind of curves like this, kind of curves up like that. Now, it's kind of interesting to know what happens if you maybe put a negative 1 in there, because you can't have a negative area. But what is negative 1 times negative 1? It's positive 1. Negative 2 times negative 2 is positive 4, and so on. So the rest of the story looks something like this, although it wouldn't really work for squares, but that's how that equation would work. And so this shape is called a parabola when you have a quadratic equation with a square in it. You have this U shape or an upside down U shape called a parabola. Okay, let's take a look at this last one. If you have you, you're one person. But if you go back 1 generation, you have mom and dad, there's 2 people. And if you go back 2 generations, you should have 4 grandparents. Your mom's mom and dad and your dad's mom and dad. And if you go back 3 generations, you should have 8 grandparents. And if you go back 4, 16 grandparents. Now this one, it goes up, increases a little bit more steeply than the previous one we just did. And so it looks something like this. Y equals 2 to the x. This time the x is the exponent instead of the 2. And what would happen if you put in some negative numbers for x? Well, you can tell that we're doubling each time we go forward, so we half each time we go backward. So it ends up looking something like this. And it gets closer and closer to the x-axis, but never touches it. This is called an exponential function because the x is in the exponent. It's number 1, absolute value function. Number 2, quadratic function. Number 3, exponential function. These are all examples of functions where you have one output for every input given, and these are nonlinear functions. So hope this made some sense to you. Thanks.